Greetings, friends. Direct variation. Y varies directly. Y varies directly with x. That's how you can read the above equation. And A is some non-zero constant. Now, what does this mean? First, I can show you what it is. Here is a direct variation equation. As you can see, we have y varies directly with x with a constant of variation of 5. So how does this thing behave? Well, it behaves by changing in a constant manner every time, depending on what x is. If x were 1, you can obviously see the result for y would be 5. If x were 2, the result would be 10. If x were 3, the result would be 15. And you can see that this is changing at a constant manner. So the constant of variation is this 5. It's changing by 5 every single time. Okay, here's an example where you can see direct variation in action. The force, F, required to stretch a spring varies directly. So right away, we're thinking y equals ax. But it's not y that varies directly, it's F. So F varies directly with what? Let's see. The F varies directly with the amount the spring is stretched, S. Okay, so it varies directly with the amount the spring is stretched, S. And you still have this constant. This A will be some number eventually that'll help us represent the force in terms of how much the spring is stretched. If 8 pounds is needed to stretch a spring 8 inches, we need to then write a direct variation equation that relates F and S. Well, let's go back. If the force required F to stretch a spring varies directly with the amount the spring is stretched, 8 pounds stretches 8 inches. So it looks like the force is this idea of pounds, 8 pounds for 8 inches. I think we can figure out what A would have to be then. Because if we put in 8 for the F and 8 for the S, if we divide 8 on each side, it looks like A must be worth 1. Well, if A is worth 1, that means that F is equal to 1 times S. Okay, so the force required to stretch a spring, let's do B, 25 inches. Well, if you want to go 25 inches, it looks like, according to this formula here, that the force must be 25 pounds. That's easy enough. Let's try another. Okay. One way to keep moisture out of your basement is to paint the walls with waterproof paint. The number G of gallons of paint you need varies directly with the area A. So right away, you know something varies directly. This is the form. If it is the number of gallons that varies directly, we'll have G is varying directly with what? The A is always constant, and it looks like they're using a capital letter A. Okay. 1 gallon covers 100 square feet. Well, if 1 gallon covers 100 square feet, it looks like this constant of variation must be worth 1/100th. And if that's the case, a direct variation equation that relates G and A must be G is equal to 1/100th of A. How many gallons would you need to cover 530 square feet? 530 square feet looks like it's talking about A here. So the amount of gallons would be equal to 1/100th of 530 square feet. 530 divided by 100 would be 53/10, which looks to be 5.3 gallons. Okay, let's make some space here. And lastly, how many square feet does 8.5 gallons cover? Well, let's flip the script here. In this same equation that's representing the number of gallons that we would need for a certain area, we can say if we have 8.5 gallons, how much area could we cover? It looks like A is being multiplied by 1/100th. So if you divide by 1/100th, or multiply by its reciprocal, it would be the inverse operation. And we could get A by itself. These would cancel out, and we'd be left with A equals 100 times 8.5 is 850 square feet. These are fun. Try some examples on your own from the textbook. 3.6 has some good problems that deal with direct variation. Good luck, humans.